Okay, so on 7.2 we're going to be solving quadratic equations with imaginary solutions. An imaginary number is an I, and that is defined by the square root of -1. So basically what you're doing is you can't take the square root of a negative number, so what you will do is you will bring the negative on the outside of the square root and make it an I, and then take the square root of that positive number. Okay, so an imaginary number is square root of a negative number. We can now use the imaginary numbers I to simplify square roots of negative numbers. First, you're going to take the i's out, and then you're going to simplify the radical. So on this first one, we're going to bring the negative out. So it'll be an I, and then we have square root of 5. After you pull the I out, you're going to look and notice it's a positive 5. 5 is not a perfect square, and we can't use the factor tree to simplify it anymore. So actually, that would just be your answer there. Okay, so then looking at 2, I'm going to bring the negative on the outside. Now it's the square root of positive 25. And notice 25, it is a perfect square. Square root of 25 is 5, so that answer would be 5i. Okay, so next one, we're going to bring the negative on the outside, so that's going to make it an I, square root of 45. And then 45 is not perfect, but we can simplify it using the factor tree. So that would be 3 times 15 and 3 times 5. And remember, you're looking for your pairs, so we have a pair of 3's, and we have a 5 left over. So we're bringing the 3 on the outside, so that would be 3i. And then whatever we boxed in is what's left under the radical, which is 5. Okay, so then 4, negative on the under the radical, make it an I on the outside, and now we have the square root of 180. So we'll use factor tree. That would be 2 times 90, 2 times 45, 3 times 15, and 3 times 5. So we're looking for pairs. We have a pair of 2's, we have a pair of 3's, and then we have a 5 left over. So I'm bringing out a 2 and a 3. We will multiply those together to give us 6. And then we have that I. And then I boxed in the 5 that stays under the radical. So 6i square root of 5 would be our answer. Okay, so the next part, we are going to solve, which means you're going to be finding x. So you're finding what x equals. And notice that it says roots here. So remember, roots are your x-intercepts, and it says to sketch. So the first thing that you would need to do is go into y equals on your calculator and type in 5x squared plus 6x plus 5. If you were to type that into y equals and graph it, it would look similar to this here. Remember, your roots are your x-intercepts. So notice there's a problem here. It doesn't cross the x-axis. So that means that there's no real solution. So if this is the case, roots are the same thing as solutions, x-intercepts, they all mean the same thing. Okay, so if you were to graph it and you're finding that, and it doesn't cross the x-axis, then I want you to use the quadratic formula so that way you can find it. So the reason why is because you're going to have an imaginary solution. So your quadratic formula, x equals a negative b plus or minus the square root of b squared minus 4ac over 2a. We've already used this. Okay, so notice that a is 5, b is 6, and c is 5. So we're going to plug in here. So x equals a negative b, which is 6, plus or minus the square root of b squared, so 6 squared, minus 4, a is 5, and c is 5. That's all over 2 times a, which is 5. Okay, so remember when we were doing this before, we were finding the number that was under the radical. So 6 squared is 36. And then 4 times 5, you get 20, times 5, you get, so minus 100. So 36 minus 100 is going to give you negative 64. And that's over 10. So all I did was I found the number under the radical. It equals negative 64. Now, since we have a negative under the radical, we can't take the square root of negative 64. So we're going to do like we did on the first 4 examples, and we're going to bring that negative on the outside and make it an I. And then I have square root of positive 64. You're simplifying the radical. 64 is a perfect square. The square root of 64 is 8. So that would be negative 6 plus or minus 8i over 10. Don't forget the I because we had a negative under the radical. So we had an imaginary number. Okay, so now from here you're looking at all the outside numbers, all of these here. You're looking to see if they all can be divided by the same number. And notice we can divide all of them by 2. So x would equal negative 3 plus or minus 4i over 5. Since we can't add negative 3 and 4, we're going to leave it like that. So I is just like a variable. You can't add it unless there's another one. Okay, so these were our roots. Roots are also called solutions. Solutions, x-intercepts, and also zeros. Okay, looking at example 6. Notice this one is not in standard form. It needs to be set equal to 0 before we can do anything else with it. So I'm going to subtract 5x and add 3 to both sides. So that would be 3x squared minus 5x plus 3 equals 0. So once we have it in standard form, then we're going to plug it in. You can plug it in the calculator just to make sure. If it doesn't cross the x-axis, then you know that you have to use the quadratic formula. Okay, so if you type that into y equals, it's not going to cross the x-axis. So let's go ahead and plug it into our quadratic formula. I'll write that at the top here. Okay, so we have A is 3, B is negative 5, and C is 3. Okay, so plugging in, we have x equals a negative b, and b is a negative 5. So that will make it positive 5 plus or minus the square root of negative 5 squared minus 4 times a times c all over 2 times a. Okay, so we're finding, once we've plugged it into the quadratic formula, we're finding the number under the radical. So x equals 5 plus or minus, that's going to give me 25, that'd be 12, so minus 36. So that would be negative 11. Okay, so again, we have a negative under the radical. That's why it didn't cross the x-axis. So I'm going to bring that negative on the outside and put an I, square root of 11 over 6. From here, we're checking the radical to see if we can simplify it. So square root of 11, it's not a perfect square, and we can't use the factor tree to pull any of their pairs out. Okay. To check this part, look and see if they can all be reduced by the same number, and they can't. So that's as far as I can go. Looking at this next one. Notice that it's already set equal to 0, so we don't have to do that step. You can plug it in the calculator just to make sure, see if it crosses the x-axis, and it's not going to. So a will equal 1, because that's the number in front of x squared. B will equal 4, and C will equal 16. Plugging into your formula, x equals a negative b, so a negative 4, plus or minus the square root of b squared, minus 4 times a times c, all over 2 times a. So we're finding the number that's under the radical. So 4 squared 16 minus, that would give you 64. So 16 minus 64 gives you a negative 48. Okay, so we're going to bring the negative on the outside and make it an I. It's an imaginary solution here. So now 48's positive. 48's not a perfect square, but we need to come over on the side and see if we can simplify it using factor tree. So 2 times 24, 2 times 12, 2 times 6, and 2 times 3. So we have a pair of 2's and another pair of 2's, and then we have a 3 left. So we're bringing out 2 2's, that would make 4, square root of 3. So when I bring out the 4, I'm putting it before the I, and then the square root of 3. From here, you're checking all of the outside numbers. They all can be divided by 2. You're never going to change what's under the radical whenever you're reducing it at the end. So you're only looking at the outside numbers. So x would equal, they all can be divided by 2. So negative 2 plus or minus 2i square root of 3. And then you don't have to put over 1. So those would be your imaginary solutions, roots, x-intercepts. They all mean the same thing.